Hello everyone, hope you all are doing good. I am Anjana from Learnohub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 9 Physics Chapter 9 Current Electricity. We will be discussing the topics Simple Electric Circuit, Potential Difference and Resistances. Are you all ready for the session? Let's begin. Simple electric circuit. So what is an electric circuit? We have discussed about the different components: cell, battery, bulb, rheostat, connecting wires. All these are put together to form an electric circuit. The simplest electric circuit is a circuit that you see in a torch. In a torch, there will be a switch, there is a bulb and a cell. Only these three components are there. So here you can see this is a circuit. It contains only a cell and a bulb. Okay. So there is a cell, positive terminal connected to one end of the bulb. The other end is connected to the negative terminal. Only this much is there. So when this connection is made, the bulb glows. When this connection wires are removed, the bulb does not glow. Okay. So here we have the diagram. So here you have a cell, positive terminal, negative terminal, and this is a bulb. Bulb can be represented in this way. Okay. This is a symbol for a bulb. Okay. Then you can connect a key also. That is a third component, key or a switch. So here positive, negative. Then you can put a key wherever it is, put a key, then a bulb. So this makes a circuit. Okay. So here you can see this is an open key. Okay. When you put the key, when you plug it in, what happens? The bulb will start to glow. Okay. So next is a circuit which includes other components like ammeter, voltmeter, rheostat. So we'll draw a circuit which contains these components. Okay. So there is a bulb. Okay, then you have an ammeter. So this is a symbol for an ammeter. Then you have a key. Then you have a battery. So battery is made up of 2 or 3 cells. 2 or 3 cells put together makes up a battery. Then you have the rheostat. So this is how the rheostat is represented. Okay, the other end is connected to here. Then you have a voltmeter. Voltmeter is always connected parallel to the component, okay, to these components, that is main component, that is the load, bulb or heater, whatever it is, voltmeter is connected in parallel, okay, and ammeter will always be connected in series. Series means a continuous chain connection, okay. Now, so here you have the battery. This is a positive terminal, this is a negative terminal. Positive terminal of battery should be connected to ammeter's positive terminal. So here comes the negative terminal. Also, the positive terminal of the battery, which side it is there, the positive of the voltmeter also should be on the same side. That is continuously positive should come, continuously negative should come. Okay. So this is a circuit which contains other components. Apart from here, you have only bulb, battery and the key. Okay, or the switch, the simplest circuit it is. So here you have included ammeter to get the current reading, voltmeter to get the voltage reading. Then you have the rheostat to vary the resistance on resistance. So when you vary the resistance, what happens? The current will change. When resistance increases, the current will decrease. When resistance decreases, current will increase. So depending on the current, what happens? The glow of the intensity of the glow of the bulb will also change. Ammeter and voltmeter reading will also change. Okay, so this is a circuit. This is a simplest circuit and the circuit with other components are included. Okay, now you can say that when the circuit is in this way, okay, initially let's say the key was given, that is the key was plugged in. So suddenly when you take the key, what happens? Okay, that is it becomes an open circuit. So in an open circuit, current cannot flow. What happens? From the battery it will start. Here it is not continuous. There is no connection. What happens? The current will stop there. It won't reach the ammeter, it won't reach the voltmeter, it won't reach the bulb. Okay. So this is what happens. Now, when the key is plugged in, okay, plugging in the key, what happens? It becomes a closed circuit. So when the circuit is a closed circuit, what happens? The current can flow through the circuit. So we know that how is the flow of current? What is the direction of flow of current? Electrons will be starting from the negative terminals and flow in one direction. Okay, and the current flow will be in the direction of positive ions. That is, current flow will start from the positive terminal, okay, towards the negative terminal. In this direction, current will be flowing. Okay. And the bulb will start to glow. So when you check the ammeter and voltmeter, you can get the ammeter and voltmeter reading. That is, initially when the circuit was open, current was not allowed to flow or the key was not plugged in. In that case, ammeter reading, voltmeter reading will be 0. Okay. And to this end, the needle will be there. Okay. To the left end, the needle will be there. So what happens when current flows through the circuit? Ammeter reading will rise and the voltmeter reading will also rise. Okay, so it becomes a closed circuit. Next, the third case is when you want to change the intensity of the glow of the bulb. Okay, so lighter or brighter you can make. How you can change this? Using the rheostat. So we have said that in the rheostat or variable resistor, there is a jockey. So when the jockey is moved towards the left means what is it? What does it mean? Resistance is decreasing. Resistance decrease. So when resistance decreases, what happens to current? Current will increase. They are inversely proportional. Current will increase. Okay. And so you can see that the glow of the bulb will also increase. So when you move the rheostat, that is the jockey of the rheostat towards the right, what happens is the resistance value is increasing. When resistance increases, current decreases. So when current decreases, what happens? The glow of the bulb will also decrease. So this is the third case. So why do we use a variable resistor or rheostat? To change the intensity of the glow of the bulb. Okay. To change the amount of current that is reaching the device. It can be controlled using a variable resistor or rheostat. The path along which current flows is called a circuit. So this path, using connecting wire, you are making a path, and this path is called the electric circuit. Insulators. So what are insulators? You have heard this word before in smaller classes as well. So what are insulators? Insulators are substances which do not allow the flow of current through them. That is, they do not conduct electricity or they offer a resistance. Okay, for example, when you take the case of a plastic bottle. Okay, plastic is an example of an insulator. It cannot conduct electricity. In the circuit, if you are keeping plastic somewhere between the connecting wires or between any devices, there the current will get stopped. It cannot allow the current to flow further. Okay, so plastic is the first example of an insulator. Next, wood. When you take wood, okay, if you are using wood to complete a circuit, wood will not conduct electricity. That is, current is not allowed to flow through the circuit. Next, when you take glass, glass is another example. It doesn't conduct electricity. It is an insulator. Then, paper is an insulator. Leather is an insulator. Next, when you take pure water, okay, pure water cannot conduct electricity. What is the reason? Because it doesn't contain any ions. When you take a sodium chloride solution, NaCl, salt solution, you can see that there are positive and negative ions. Sodium positive ions and chlorine are the negative ions. Okay, so these ions will help to conduct electricity. So when you take a case of pure water, there are no ions present in it and it does not conduct electricity. So pure water is another example. Okay, so these are examples of insulator. Insulator means there is some resistance offered. That is, the current is, what is resistance? Resistance means there is some stopping. You are resisting the amount of current that is flowing. You can control the amount of current flowing. So when it comes to the case of insulators, there is high resistance. They are offering high resistance. They do not allow the current to flow at all. The current is completely stopped from flowing through the circuit. Conductors, just the opposite of insulators. Substances which allow current to flow through them are called conductors. Okay, easily current can flow through them. So why do we get electric shock? Because our body is a conductor of electricity. So you can say that human body is an example of conductor. Okay, human body can conduct electricity. Okay, next, impure water can conduct electricity. Okay, pure water cannot conduct because ions are not present. But when you take the case of impure water, some positive and negative ions will be present and they will conduct electricity. Salt solution can conduct electricity. Next, copper. Metals, mainly metals. Copper, aluminium, silver, steel. All these are conductors of electricity. So when you take the case of these, you can see free electrons present. And this free electrons, we know that electrons move in one direction and current flows in the opposite direction. So free electrons should be present for the conduction of electricity. When you take the case of insulators, there are no free electrons present. Okay, so they cannot conduct electricity. When it comes to the case of conductors, there are free electrons present and free electrons helps to conduct electricity. So these are the examples of conductors. Closed and open circuit. A closed circuit means when you know that key or a switch is being used in a circuit. So when the key is plugged in, current is allowed to flow through the circuit. That is, the circuit is a conducting circuit. Okay, in that case, we call the circuit as a closed circuit. An open circuit is when the key is not plugged in or the switch is in the off state. In that case, current cannot flow through the circuit. It is broken. Okay. So what happens? The current cannot flow through the circuit and the bulb does not glow. If the bulb is a device used, it does not glow. In that case, we call it as an open circuit. Okay. So current flows only if the circuit is complete or a closed circuit. If the circuit is open, current does not flow. Okay. Now you can see that here there is a dry cell AB. Between the terminals of the dry cell A and B, a bulb is connected. Okay. So here you can see there is a metal wire. Two metal wires are used. Metal wire, metal wire. Using the two metal wires, the dry cell is connected to the bulb. Okay. You can see here the bulb glows. This is a complete circuit. This is a closed circuit. Okay. Here the bulb glows. Now take this case. What can you see? In this case, metal wire is used. Okay, two metal wires are used. Dry cell is there, but the bulb does not glow. So when you check, you can see that the circuit is broken. Till here it is there. Here you can see a gap. Okay, so since there is a gap, what happens? The current cannot flow through the circuit. Okay, the current flow is stopped. Current will reach this point. What happens then? It cannot flow further. Okay, so this is an example of a open circuit. Okay, the current flow is stopped and the bulb does not glow. Now take the third case. You can see it is a closed circuit. There is a complete connection. So what is the difference here? You can see metal wire is used. One wire used is a metal wire and the other one is a thread. Okay, thread is for example a wool thread. Wool is an insulator. Okay, can insulator conduct electricity? No, right? So here you have a dry cell, here you have a bulb, but in this case, even though it appears to be closed, since a thread is being used, which is an insulator, we can say that the bulb does not glow. The reason is that insulators cannot conduct electricity. So understood what is a closed circuit and open circuit? The device should work. Okay, the bulb should glow. Only in that case we can say it is a complete circuit or a closed circuit. This appears to be a complete or closed circuit, but since an insulator is being used, you cannot call it as a closed circuit. It is an open circuit. Okay, flow of electrons between the conductors. So here you can see tank A and tank B. Okay, water is filled in both the tanks and you can see that the water level is same. Okay, same level of water is there. Okay, water is exact the same level in both tanks, so water will not flow. There is no flow of water because they are at the same level. Now to consider this case, here you can see in tank A this is a water level and tank B this is a water level. Here what happens is the water will start flowing from tank A to tank B, okay, until they reach equal C. Okay, that is the water level in tank A and tank B becomes equal. Until then the water will start flowing from A to B, because here you can see in A the water is more. So where the water is more, from there it will move to the place where the water is less. Okay, for example, if you have a hot body and a cold body, okay, when you keep them close, what happens? The temperature of the cold body will increase and the temperature of the hot body will decrease. What is happening? Heat is getting transferred from the hot body to the cold body. So where it is more, from there it will go to a region where it is less. Okay, similar thing will happen. So here you can see that how is the flow of electrons. So when you take two conductors, we will be discussing three cases. Okay, first case is taking a conductor A and B such that A is positively charged. Okay, positively charged. So we know that because of the flow of electrons only current is there. Yes. So B is uncharged. So here in which direction does the current flow? You will be able to see that electrons will flow from a region where the concentration of electron is higher to a region where the concentration of electrons is less. So here since A is positively charged, which means there is a deficit of electrons. Yes. So when they are connected with the metal wire, you are using a metal wire to connect them. What happens is from this uncharged conductor B, the electron starts flowing to A. Okay. Now the second case, you are taking two conductors A and B such that A is negatively charged. Okay. Negatively charged means excess of electrons compared to the uncharged B. So here when connected with metal wire, what happens? Using metal wire, you are making the connection. What happens here? In this direction will the electrons will be flowing from a region where there is a higher concentration of electrons to a region where there is a deficit of electrons. Now the third case, you are taking a positively charged conductor A. A is positively charged and B is negatively charged. Okay, in which direction does the electrons move? Negatively charged means there is an excess of electrons. Positively charged means there is a deficit of electrons. So in this direction, so when connected with metal wire, this is the direction in which the electrons flow. In which direction electrons flow? Just in the opposite direction there will be current flow. When two charged conductors are joined by metallic wire or they are placed in contact, free electrons flow from a conductor having higher concentration of electrons to the conductor having lower concentration of electrons. Understood? Same. When you compare to this case where there is more water, from there water will start flowing to a region where there is less water. Or when you take a hot body and cold body, the temperature, that is the heat transfer is from the hot body to the cold body. Okay, what happens then? The temperature of the cold body increases, temperature of hot body decreases. Here what happens? The number of electrons in the uncharged conductor is decreasing and the number of electrons in the positively charged conductor is increasing. Okay, understood? Direction of the electric current, conventional and electronic flow. So we have now discussed the flow of electron, direction of flow of electrons. When you have a positively charged conductor and an uncharged conductor. Or the second case is when you have a negatively charged conductor and uncharged conductor. Third case, positively charged conductor and negatively charged conductor. So now we are going to, with this in your mind, you can find the direction in which the current will be flowing in each case. So we know that when you drop an object to ground, what is happening? The object is moving from a level, higher level to a lower level. Higher level means from the earth it is at a higher distance. Lower level means from earth it is at a lower distance. So this can be explained with the by keeping in mind gravitational potential. So when you have a ball in your hand, when you are holding it here, it means the height is higher. You have heard about the potential energy. So this is a point where the gravitational potential is higher gravitational potential region. So when it falls to the ground, what is happening? The height has decreased, okay, which means there is a lower gravitational potential. Okay, from higher gravitational potential, the body is moving to a lower gravitational potential. Okay, next when you take the case of water, okay, so water in two tanks was taken, A and B, water is flowing from where there is greater height. This is because of hydrostatic pressure. Here it is not gravitational potential, here it is hydrostatic pressure. Okay, so hydrostatic pressure, due to hydrostatic pressure, the water will flow from a region where water is higher to a region where water is lower. Higher temperature to lower temperature, two bodies at different temperatures when taken, the heat will flow from a higher body at higher temperature to a body at the lower temperature. Okay, so we have discussed the different cases. Okay, now electron flow, which means when you take two conductors A and B. Okay, let's say there is excess of electrons in A, excess of electrons. If there is excess of electrons, it means the body is at a lower potential. Okay, lower potential. If there is a deficit of electrons, then the body is at higher potential. Higher potential. Okay, for example, when you take battery or a cell, Positive terminal, negative terminal. Positive terminal means higher potential and negative terminal is the region of lower potential. Okay. So higher potential and lower potential. Now, excess of electrons, for example, when you take a negatively charged conductor and an uncharged conductor. Okay. In this case, uncharged conductor, comparing, you can see there is a deficit of electrons here. So, in which direction does electrons flow? This is the direction of electron flow from the negatively charged conductor to the positively charged, to the uncharged conductor. The electrons will be flowing. If this is the direction in which the electrons flow, current will flow in just the opposite direction. That is from higher potential. Current flow is from a region of higher potential to a region of lower potential. Okay, so this current we call the conventional current, and electronic flow is the flow of electrons. This is electronic current. Okay, so understood. So how to find the direction in which the current is flowing. Okay, so this was the first case we discussed, that is a positively charged. This was the second case that we discussed, that is negatively charged conductor and an uncharged conductor. Now take the first case, a positively charged conductor. A is a positively charged conductor and B is an uncharged conductor. In this case, in which direction does the electrons flow? Electrons flow from here to here. Now, which one is at a higher potential? Positively charged will be at higher potential. Higher potential. Deficit of electron, higher potential. Excess of electrons, lower potential. Lower potential. Okay. Which direction is the current flow? Current flow will start from A to B. Okay. Now, positively charged conductor and a negatively charged conductor. Third case. A is positively charged conductor and B is negatively charged conductor. In which direction does the current flow? Which one is at a higher potential? A is at a higher potential and B is at a lower potential. Okay. Here electrons flow from B to A and the current flow is from the region of higher potential to lower potential, which means from A to B. Clear? Next is potential difference. So when you take the case of a battery, there is a potential, it's able to create a potential difference. Okay. So what is a potential difference? Before understanding potential difference, we need to know what is a potential. So when you take two bodies, if the two bodies are positively charged, okay, positively charged, what happens? There is repulsion. Okay. When a positive and negatively charged bodies are taken, there is attraction. Okay. When a negatively charged body and negatively charged body is taken, again there is repulsion. So here in all these cases, there is some difference in the potentials and only because of this all these is happening. So to create this difference in potential, some work should be done on the charge. Okay. So first we'll speak about potential. What is electric potential? So electric potential is when we are considering that work to be done in bringing a unit positive test charge from infinity to a point. Okay. So the work done in bringing a unit positive charge from infinity to a point is called the electric potential. Electric potential is represented by the letter V. Electric potential V is equal to W, which is the work done divided by the charge. Okay. The work that is to be done to bring the charge from infinity, from any point at infinity to a given point is called the electric potential at that point. Okay. Now, what is potential difference? So, this type of electric potential, every point will be having. Okay. Now, when you want to understand what is potential difference, it is when there is a work done in bringing a charge. Okay. Bringing a charge from one point to another point. Okay. So, if you take two regions, here there will be an electric potential, say V1. V1 is the electric potential at this point to bring a unit positive test charge from infinity to this particular point. Okay. And here there will be a potential V2. So, potential is V2 because this is the potential, electric potential at this point when a unit positive test charge is to be brought from infinity to this particular point. Okay. So, here both these points we know V1 and V2 are the electric potentials. So, when you find the difference, you will be getting the electric potential difference, which means from this point to this point, if you have to take the charge, that positive test charge should be taken from this point to this point. Okay. Some work should be done. This work is called the work done in taking a unit or transferring a unit positive test charge or a charge from one point to another point is called the potential difference. Okay, so V1 minus V2 will be equal to W divided by Q. Okay, this is the potential difference. Electric potential and electric potential difference are scalar quantities. Scalar quantities means there is only magnitude and no direction. Okay, which is represented by the letter V. Okay, and its unit is also V. From Alexander Volta, from the scientist's name, volt is the unit which is represented by, volt is the unit and represented by capital letter V. Understood about electric potential and potential difference? Okay, so potential difference, the potential difference between two conductors is equal to the work done in transferring a unit positive charge from one conductor to the other conductor. If you are taking from A to B or B to A, the value of electric potential difference will be the same. Okay, 2 points, A point, B point. If you are taking from A to B or B to A, the value will be the same. Now, the unit of potential difference. So, what we have said, potential difference relation. Potential difference is equal to work done divided by charge. Okay. V is equal to W divided by Q. Okay. What is W? What is W? W is work done. What is the unit of work done? Joules. Okay. J. What about the unit of charge? Unit of charge is coulomb. Joule per coulomb. Okay. So, one unit of potential difference is joule per coulomb. So, we know that in many cases, we will be taking another unit from scientist's name. So, that type of a unit is volt. Okay. Unit of potential difference is taken as volt, represented by capital letter V. Okay. So, we have said that this is a scalar quantity. Potential difference and electric potential are scalar quantity. So, when do we get 1 volt? Potential is a potential difference 1 volt. How do we get potential difference 1 volt? So, we know that when you take the case of current, the current is 1 ampere when 1 coulomb is the charge which is acting for 1 second. Yes. The rate of change of charge is called the current. Okay. So, 1 ampere current is when 1 coulomb of charge is passing in time 1 second. Okay. So, when do we get 1 volt potential difference? 1 volt potential difference is when 1 joule of work is done in transferring a charge of 1 coulomb from one point to another. 1 volt is equal to 1 joule per 1 coulomb. Okay. So, potential difference between 2 points is said to be 1 volt if work done in transferring 1 coulomb of charge from one point to the other point is 1 joule. Okay. 1 coulomb charge is to be transferred and the work done for it is 1 joules. Okay. Electrical resistance. Consider a case, a ball is rolling through a floor. Okay. When the ball is rolling, you suddenly go keep your hands on this ball. That is, you are trying to stop the ball or you are slowly touching the ball. What happens? Either the ball will come to rest or the speed of the ball will decrease. Okay. So, you are restricting it. Okay. You are acting as an obstruction. You are resisting the flow of the ball or the movement of the ball is being restricted. Okay. So, you are offering a resistance. You are resisting it. Okay. Similarly, when current is flowing through a circuit, okay, when electric current is flowing through a circuit, there are chances of resistance. Okay. There will be some obstruction and this obstruction we call the electrical resistance. Okay. Something that is stopping or controlling the flow of current. How much current should reach? It will be controlled something. Okay. So, the obstruction offered to the flow of current by a conductor is called the electrical resistance. Okay. And this electrical resistance can be offered using a device called resistor. Okay. Resistor is a device which is represented in this way and this resistors will offer resistance. Okay. Or you can adjust the resistance. Okay. You can change the resistance. So, we have said, so when the jockey is moved in case of a rheostat, okay, a rheostat offers variable resistance, that is your resistance can be changed. So, when you take the jockey of a rheostat towards the left, what is happening? The resistance is decreasing, more current can flow. So, you can increase the resistance. Okay, what should be done? You have to move the jockey of the rheostat towards the right end. So, when you are moving it towards the right end, what happens? The current will decrease. When the current decreases, the bulb glowing, okay, the glow of the bulb will also decrease. Okay, now what causes resistance? So when you take a metal wire, the metal wire will be containing electrons. So there is random motion of electrons. Okay, what does random motion mean? It will be moving. That is, electrons will be moving in different directions. So here you can see this positive sign. Okay, this represents positive ions. Positive ions. And E represent electrons. Okay, so you can see that there are positive ions present inside the metal wire and the electrons are moving randomly in different directions. So when it is connected to a circuit, okay, what happens is, when you connect it to a circuit, there is a battery or a cell, okay, it will be having a positive and a negative terminal. Now, in which direction does the electrons flow? The flow of electrons will always be from the negative terminal to positive terminal. So here when you compare, you can see this shows the electrons random flow, but here you can see the electrons are always moving from the negative to positive. Okay, negative to positive direction, you can see the electrons are moving. Now what happens is, when these electrons move, they can go hit other positive ions. Okay, their aim is to move towards the positive terminal, but there are chances they can go hit the positive ions present, or they can go hit other electrons. Okay, so during this, okay, actually the electron should flow only to the positive terminal, without any restrictions they should be able to flow. But here what happens, when it goes strikes the positive ions or it strikes other electrons, there is some resistance. Okay, so this creates electric resistance inside a metal wire. Understood? Okay, so this is a cause of resistance in a circuit. Because of the presence of positive ions, the electrons will get drifted to different direction, though they have a tendency to move to the positive terminal. Okay, so this drifting of electron is caused by the resistance that is offered inside the metal wire. Next, Ohm's law. Ohm's law is a law which gives a relation between the electric potential difference and the current I. Okay, so according to Ohm's law, the Ohm's law states that current flowing through a conductor is directly proportional to the potential difference applied across its ends, provided its temperature is constant. At constant temperature, when the potential difference increases, current also increases. They are directly proportional. So this is a statement of Ohm's law. V proportional to I. Electric potential difference is directly proportional to the current. Okay, so this when you take a metal wire or a conductor, okay, the potential difference between the two terminals of a conductor is directly proportional to the current flowing through it, okay, at a constant temperature. Okay, now to remove this proportionality, we can insert a constant. This constant is R. V is equal to IR, and R is the resistance. Okay, resistance of the conductor is R. V is equal to IR is the mathematical expression for Ohm's law. Okay, V is equal to IR. From this, we will be having, if you are given the current and resistance, you can find the potential difference. When the potential difference and resistance is given, you can find current. Current I is equal to V by R, and R is equal to, resistance R is equal to V by I. These relations are possible. Okay, got it? Now, if a conductor, okay, if a conductor, it obeys Ohm's law, we call it a ohmic conductor. Okay, and if it doesn't obey the Ohm's law, it is called a non-ohmic conductor. Okay, two types of conductors, ohmic conductors and non-ohmic. Ohmic, it obeys the Ohm's law. If it doesn't obey the Ohm's law, it is called a non-ohmic conductor. VI graph. According to Ohm's law, we have said that the potential difference and current are directly proportional. When current increases, potential difference also increases. So here we can plot a graph between the potential difference and current. Okay, here potential difference is taken along the x-axis and the current is taken along the y-axis. Okay, some values are taken. So these values for potential difference and current are noted. So current values can be noted using an ammeter. Consider a circuit. In the circuit, current is flowing. The circuit contains an ammeter, a voltmeter, a rheostat, a bulb, switch, whatever it is, whatever are required in a electric circuit, all that are there. Okay, so when the key is plugged in, current starts flowing. Okay, current starts flowing. You are noting two values. That is, first is the current value and the potential difference value. So we got 0.2, 0.5. Okay, next you are changing with the variable resistor, you are changing the resistance. Okay, so when resistance is changed, you will be getting a different value of current. So here current is increasing, which means you are decreasing the resistance. So decreasing resistance with the help of jockey or adjusting a value, you are noting the ammeter reading, which is 0.4 in amperes, and the potential difference in volts is noted to be 1. volt. Okay. Next, again you are decreasing the resistance by moving the jockey towards the left. You are noting the ammeter reading 0.6 and the potential differences, that is the voltmeter reading is 1.5. Next, when the ammeter reading becomes 0.8, that is further decreasing the resistance, the voltmeter reading becomes 2 volt. When the ammeter reading is 1 ampere, it becomes 2.5. So, we can plot a graph. Okay. Here, current is taken along the y-axis, current in ampere and voltage or the potential difference in volts. Okay. So, here check the values for current 0.2, 0.4, 0.6, 0.8, 1. Okay. So, this type of values can be given 0.2, 0.4, 0.6, 0.8, 1. Okay. So, here when you take the scale, okay, you will take along the x-axis as well. You have the values 0.5, 1, 1.5, 2, 2.5. Okay. So, I will take 0.5, 1, 1.5, 2, 2.5. So, these are the values. So, here along the x-axis, 1 unit is taken as 0.5 volts. Along the y-axis, 1 unit is taken as 0.2 ampere. Okay. Now, let us plot the points. When the current is 0.2 ampere, the voltage is 0.5 volt. Okay. Potential difference is 0.5 volt. Where does the point come? 0.5 volt, 0.2 ampere. This is a point. Next, when the current is 0.4, the potential difference is 1. This is the point. Okay. When current is 0.6, potential difference is 1.5. This is a point. Okay. 0.8 current, 2 is the potential difference. 2.5 is the potential difference when the current is 1. So, this is a point. Okay. So, when you join these points using a straight line, okay. So, this straight line gives you the complete graph, VI graph. Okay. So, when you find the slope of this graph, what is the slope of this graph? Okay. I am making a triangle. Okay, so here you will be getting slope. Slope will be equal to delta I divided by delta V. Delta means change in current by change in the potential difference will give you the slope. Okay, we know that according to Ohm's law, V is equal to IR, which means R is equal to V by I. Okay, so when you take 1 by slope, what do we get? 1 by slope will be equal to delta V by delta I. Okay, change in voltage by change in current. So, which is the resistance? Okay, so when you take the inverse or the reciprocal of the slope of a VI graph with V along the x-axis and current along the y-axis, we will be getting the electric resistance. Now, if you are plotting a graph in such a way that the current is taken along the x-axis and the potential difference is taken along the y-axis, okay, then the slope will be equal to change in potential difference divided by change in current, okay, which is the resistance. So, when you take a graph with current taken along x-axis and voltage along or the potential difference along y-axis, you will get a slope and this slope will be the electrical resistance of that circuit, okay. And when you are taking a graph with current along the y-axis and the potential difference along x-axis, then you will have to take the reciprocal of the slope to get the electrical resistance. Okay, this resistance is a scalar quantity. Okay, so we have discussed about electric potential difference and resistance. All of these are scalar quantities. There is only magnitude and no direction. Unit of resistance. So, what is resistance? Relation for resistance? Resistance is equal to potential difference divided by current. Why? Because according to Ohm's law, where V is proportional to I, we got V is equal to IR, which means R is equal to V by I. Okay. Then what is the unit of resistance? Unit of resistance will be unit of potential difference divided by unit of current. What is the unit of potential difference? Volt divided by unit of current, ampere. Okay. Volt per ampere is a unit of resistance. So there is another unit which is the most commonly used unit, or the SI unit. The unit of resistance is represented by the symbol omega. Okay, this Greek letter is used to represent the unit of resistance, which is ohm. Okay, so ohm is the unit of resistance. Okay, unit of resistance is volt per ampere, but the most commonly used unit of resistance is ohm. Factors affecting the resistance of a conductor. There are 4 factors. The first one is the material of wire. Second is the length of the wire. Third, the area of cross section of wire. And the fourth is the temperature of the wire. So, material of a wire. So, we know that different materials can act as conductors. For example, metals like copper, aluminium, silver. All these are conductors of electricity. Okay, if you are taking a copper wire, an aluminium wire and a silver wire which is of same length. Okay, this is the length and this is the area of cross section. Even though you are taking 3 wires of equal length and equal area of cross section, the resistance offered by them will be different. Okay, so the reason for this is it depends on the material. Okay, different material will be containing electrons. Yes, their movement will be different. Okay, their flow will be different. The collision that they make with the positive ions that is contained inside the metal wire will be different. So, due to this reason, depending on the material of wire, the resistance offered will also be different. Okay, so when you take good conductors of electricity. Okay, when you take good conductors of electricity and insulators. In case of insulators, you can see the flow of electrons. There is no flow of electrons. Electrons are stable. In that case, there won't be any current allowed to flow. That is, it is offering complete resistance. Okay, it doesn't allow the current to flow. But when you consider good conductors of electricity, the resistance will be less resistance. Because good conductors of electricity means they will allow the flow of current. Okay, they will easily allow the flow of current through them. So, less resistance. So, this is the first thing, material of wire. Depending on the material, what can change? The resistance value can change, even though the wire are taken are of same length and same area of cross section. Now, the second point is the length of wire. Okay, so when the length of wire increases, the electron should travel more distance. More distance means their collision with the positive ions and the other electrons will be increasing, which means the resistance will also be increasing. Okay, so when you take 2 wires, this is the first wire, this is the first wire and this is the second wire. Okay, in this wire, the electrons have to travel only this distance. Okay, but in this wire, the electron should travel a more distance, more collision can happen. The resistance offered can also increases, which means the resistance of a wire is directly proportional to the length. Okay, when length increases, the resistance offered will also increase, which means the conduction will decrease. Okay, conduction means the flow of electrons. Okay, means the electrons flow in the opposite direction, current should flow. Since the resistance offered is increasing, what happens? Current flow will decrease. Okay, now the third point is the area of cross section of the wire. 2 wires you are taking. So, this is your first wire. Okay, and this is your second wire. Let's say they are of equal length. So, you can see the area of cross section has increased, which means the space in which the electrons move is increasing. Electrons have got more space to move in this case. Okay, so what happens is when area of cross section increases, the number of collision with the positive ions will decrease. Okay, therefore the resistance will also decrease. Okay, so area of cross section and resistance are inversely proportional. When area of cross section increases, resistance decreases. When area of cross section decreases, resistance increases. Okay, now the fourth point is the temperature of the wire. So when temperature increases, when you heat some device, what is happening? When does the water boil? You can see that the vibrations you are able to see. Okay, the bubbles you will be able to see. So similarly, when you take a metal wire, when you are heating it, what happens? The flow, that is the electrons will get, the speed of the electrons will increase. Okay, when the speed of electrons increases, what happens? Their collisions will increase. Okay, therefore the resistance will also increase when the temperature increases. Okay, there is random motion of the electrons and this will lead to an increase in resistance. Efficient use of energy. So, energy should be used in an efficient manner so that energy will be there for the future generations as well. So we have to adopt eco-friendly practices in order to avoid the wastage of energy. So some of the eco-friendly practices are given here. First one is pressure cooker should be used instead of ordinary vessels. So when pressure cooker is used, you can save energy. The food gets cooked more easily. Okay. So in case of pressure cooker and when you're using an ordinary vessel, the same gas stove you will be using. Okay. Using the same gas stove, you will be preparing the food. So here in the first case, that is when pressure cooker is used, because of the pressure inside the cooker, the food gets cooked more faster. Okay. That is, you can save the energy. You can off the stove more earlier compared to when you are preparing the food in an ordinary vessel. Second one is saving electricity. Switch off the device when not in use. So whenever you see some devices in use, for example, you are sitting in one room and in all other rooms, the light is on. In that case, you should go and off it as early as possible. Okay, so you can save the energy there because you can prevent the wastage of energy. If you are not using, keep it off. Now the third one, by reduction in pollution using those fuels which create very little or no pollution. Okay, instead of petrol and diesel, we know petrol and diesel, all these causes pollution. You have to switch to more eco-friendly ways. Okay, you can use cycles, you can walk. In all these cases, or electric scooters can all be used so that the pollution can be reduced. Next, the fourth one, use of solar water heater instead of LPG for heating water. So in case of LPG, it is causing pollutions and all. That is, there is wastage of energy as well. So you have to switch on to solar water heater because here the source is sun. Okay, solar energy will never get exhausted until the end of this universe. Okay, till the end of this universe, we will be having sun and hence solar energy will be available. So use of solar water heater instead of LPG. Okay. Fifth one, use of solar energy wherever possible, whenever possible to produce electricity. We know the conversion law of conservation of energy state that energy can be converted from, energy can neither be created nor be destroyed but can only be changed from one form to another. So here, when you use solar energy, you can use the solar energy and change it into the different forms and make it use. Okay, because solar energy will never come to an end. Social initiatives. Due to rapid growth, due to urbanization and industrialization, the use of energy is being increasing. Okay, so this is leading to a decrease in the energy that is for future. So some social initiatives should be taken for the efficient use of energy. First one is use of alternative form of energy such as solar energy, biomass energy, geothermal energy, wind energy, etc. So these energies are not always put into use. So this should be used more. Okay, so that we will be having energy for the future. Okay, next is do not waste energy uselessly. That is the same thing. That is keep the switch, keep the lights off when not in use. Whenever you are using, you keep it on. All other times, do not keep it on. Next, the third one, use of public transport should be preferred. If you are considering in the same apartment, okay, there are many people who will be traveling in a different vehicles. So if all of them can travel the same bus, the pollution caused will be decreasing. Okay, so in 4 houses, 4 cars will be there. Okay, so daily these 4 cars will be burning petrol. Okay, which is causing pollution. Or in the same house, sometimes a child will be going in a bike. The parents will be going in 2 different vehicles too, the husband will be going in a car and the wife will be going in a scooty. So 3 vehicles are causing more pollution. If all of them can go together, which means it can decrease the pollution. Okay, energy consumption also can be decreased. Next, fourth one, replace the incandescent bulb with CFLs and LED bulbs. So you have to prefer the use of more LED bulb than CFL bulbs. So this is a fourth method that can be used to make an efficient use of energy. Let's take an example. What amount of work is needed in moving 2 coulomb charge through a potential difference of 8 volts? So what is the relation? We have potential difference is equal to potential difference is equal to work done divided by charge. So here what is given? Charge is given. Charge Q is equal to 2 coulomb. Then potential difference V is equal to 8 volt. Okay. So V is equal to W by Q. Okay. Which means W will be equal to V into Q. What is V? 8 volt into 2 coulombs, which is equal to 16, and the unit of work done is joules. 16 joules is the work done in moving 2 coulomb charge through a potential difference of 8 volts. Example 2, calculate the potential difference across the ends of a wire of resistance 2 ohm when a current of 1.5 ampere passes through it. Here we are using Ohm's law. So according to Ohm's law, we have V is equal to IR. This is a mathematical expression. So what is given in this question? Here we are given the resistance value. Resistance is equal to, resistance R is equal to 2 ohm. Okay, and the current I is given, current I is equal to 1.5 amperes. So we have to find the potential difference V. Potential difference V is equal to, okay, how to find V? V is equal to I into R, which is 1.5 into 2 equal to 3 volt. So 3 volt is the potential difference across the ends of a wire of resistance 2 ohm when a current of 1.5 ampere passes through it. Example 3, calculate the current flowing through a wire of resistance 7.5 ohm connected to a battery of potential difference 1.5 volt. So here again we are using Ohm's law. V is equal to I into R. Here we are given the potential difference V 1.5 volt and the resistance is given 7.5 ohm. We have to find the current. I will be equal to V by R. Here V is equal to 1.5 and R is equal to 7.5. This will be equal to 1 by 5. Why? Because 1.5 divided by 7.5 is 15 divided by 75. 15 into 5 is 75. So cancelling we get 1 by 5. Okay. 1 by 5 which is equal to 0.2 ampere. 0.2 ampere. That's all for today. In today's class, we have discussed about the simple electric circuit. We have discussed about the potential difference and the electrical resistance. Hope you all enjoyed the session. I'll be back in the next session. Until then, stay tuned to Learnohub. Learnohub free hai, par best hai. Thank you.